Hey guys, Mrs. Junker, we're back. Today we're talking about theories, laws, and models. The standards that we need to address are being able to select models useful in relating results of your investigations and explaining why theories may be modified but are rarely discarded. Learning goals are that you will be able to describe and analyze the different models scientists use, explain the differences between laws and theories, identify the benefits and limitations of the use of scientific models, identify and describe the role of scientific models in improving a theory, and explain why theories may be modified but are rarely discarded. Make sure we pay a lot of attention to this last standard, this last goal, because that's what we're really emphasizing today, okay? All right. Oh, remember, whenever you see a pencil, you need to write down, it's usually definitions, but you need to make sure you add that into your science notebook. So models, what are they? Models are a representation of an idea, object, process, or system that is used to describe and explain real-world events that cannot be explained easily. We have different types of models. There can be physical models like 3D solar systems that you maybe made like in third grade with the little styrofoam balls. Globes. There's also mathematical or computer models. Sometimes we see these during hurricane season. We see the predictions of where a storm might go, what the spaghetti models are looking like. Those are all computer or mathematical models. And we also have conceptual models, which are more like drawings, maps. A drawing of an atom to explain where the nucleus and where the electrons are would be a conceptual model. Benefits of models are that they helps people understand complex ideas. Sometimes we make larger things smaller so we can see them, like the whole universe, we can make it smaller. And sometimes we make smaller things larger, like atoms, so we can actually see them and talk about them. And they can help us make some predictions. Limitations are that they are often missing detail. They use approximations instead of the exact measurements, and they're a little more simplified than they necessarily should be, but it's so that we can understand it more easily. Just a quick review of some vocabulary you should already know. Hypotheses is a proposed explanation for something that can actually be tested. This is not just an educated guess. It's not what you think will happen. It's what we think will happen in these specific conditions if we are to test them. And then we can test it and find out if our hypothesis is valid or not. Facts are observations that are repeatedly confirmed. They're never final. There are a lot of things that we used to think were facts that we know now are not. And they can be modified or discarded, thrown out, if they do no longer make sense based on new data. Please write down the definition of law. A law is a generalized rule to explain a body of observations. It can be written or a mathematical statement. It is widely accepted as true, and new data can change a law. Theories. These are more than just an idea or an opinion when we're talking about scientific theories. I see another pencil. Make sure we write down the definition. The explanation of the natural world that has been substantiated through repeated experimenting or testing. Substantiated, substantial. There's lots of it. Lots of evidence to back it up. Theories can include facts, laws, inferences, and tested hypotheses. So what is the difference between a theory and a law? They have a lot of things that are in common. They're both based on empirical data. They are accepted by many or most scientists in that given field. They can be revised. They're based on tested hypotheses and repeated successful predictions. A law is what happens in the real world event. It describes the what. It does not graduate to a theory. Not every law becomes a theory. It's not quite how it works. And they can be used to predict what will happen in given circumstances. If this and this happen, then this will happen. Theories, on the other hand, explain why real world events occur. So the law is the what, and the theory is the why. These are some laws and theories that you should know. The law of conservation of energy and the law of conservation of mass, we're going to talk a lot about this year in physical science. The law of conservation of energy just says that energy cannot be created nor destroyed. It can only be transformed to another form. The law of conservation of mass is very similar. It says that matter cannot be created or destroyed. It's just changed to another form. The law of superposition, you should know from earth science. Superposition talks about how if there's not like a fault line where we've had folding and things, that top layer of Earth should be the youngest layer and the lowest layer should be the oldest layer of Earth. Law of universal gravitation talks about how different objects in space will react upon each other based on gravity. Atomic theory is another thing that we're going to talk a lot about. You might have heard a little bit about it in 5th grade, talking about how our idea and understanding of atoms has progressed throughout the centuries and how we've grown to understand them more. Cell theory, you should know from life science last year. Cells don't just pop out of nowhere. They come from pre-existing cells. And the scientific theory of evolution, you also should have discussed last year in 7th grade. All right, so here's the big thing, what we're talking about. Why aren't theories discarded often? Theories are not accepted until there's a significant amount of evidence to back it up. So usually they're tested and tested and tested and tested and tested before they become a theory, so that things that would like not be a theory for very long don't make it to be a theory. They're just different. When information comes to light, they can be modified. They often are modified or changed. Some theories have been discarded or tossed out over time when solid evidence has proved them incorrect or otherwise. So one infamous example is the geocentric model. They thought that Earth was the center of the entire universe because humans are in it. So, it has to be the center of the entire universe, right? But based on data that was collected with new technology, telescopes were brand new at some point. That was something we didn't have before that. They were able to say that, no, the Earth is not the center of the universe. We're not even the center of our own solar system. And we went to a heliocentric model where we addressed that the sun is the center of the solar system and all the planets orbit around it. All right, thanks for joining us. Have a great day.